Drop yourself into the ocean about 370 million years ago. You would not see whales, you would not see dolphins, and you certainly would not see the giant marine reptiles that appeared much later. The first thing charging toward you might be a mouth with no true teeth, yet capable of closing like a massive pair of shears. Behind that mouth is a head wrapped in thick plates of bone. This is not a submarine. It is one of the most famous armored hunters of the Devonian seas, Dunkleosteus. Welcome to the Devonian, the age when fish turned the ocean into a prehistoric arms race. Fish had already existed long before this period, but many early fish had no movable jaws. They fed by sucking, scraping, or swallowing small particles and organisms. Then jaws changed everything. A mouth was no longer just an entrance for food. It became a weapon with movable jaws. Fish could seize prey, tear flesh, and actively attack animals that were almost as large as themselves. From that moment on, the rules of the ocean changed. It was no longer only about who could hide better or who was harder to eat. Now the questions were, whose mouth was more dangerous, whose armor was thicker, and who could strike before being bitten first? That pressure produced fish that looked like underwater tanks. They were the Placoderms. Their heads and the front sections of their bodies were protected by heavy plates of bone, but behind the armor, their tails could still move and drive them through the water. It was almost as if Earth had fused a fish with an armored vehicle. Smaller predators struggled to bite through the head shield, and during fights with members of their own kind, the armor protected the most vulnerable parts of the body. Among these armored fish, few looked more intimidating than Dunkleosteus. It did not have rows of replaceable teeth like a modern shark. Instead, the edges of its jaw plates formed sharp cutting surfaces. When the mouth closed, the upper and lower plates worked like a giant biological cutting tool. Dunkleosteus did not need to slowly chew its prey. It only needed to approach, open its mouth, and close those sharpened plates around the target. For many animals in the Devonian Ocean, the danger was not simply being bitten, it was being cut apart. But the most dangerous feature of the Devonian was not that Earth created one terrifying fish, it was that several different fish upgrade paths were evolving at the same time. The first path was heavy armor. Placoderms pushed defense and close-range attack toward the extreme. The second path was speed and flexibility. Early sharks abandoned the idea of covering the body in heavy bone armor. Their lighter, more flexible bodies were better suited for continuous swimming. Their teeth could also be replaced again and again. If placoderms were the heavy tanks of the sea, sharks were developing the high-speed hunting build. The third path was the rise of bony fish. Fish with internal bony skeletons began splitting into different branches. One branch would eventually lead toward most of the fish species alive today, but another branch made a much stranger choice. Instead of competing only in deep and open water, they moved toward shallow rivers, wetlands, and shorelines. These were the lobe-finned fish. Their fins were not made only from simple fin rays. Inside them were stronger bones and heavier muscles. They looked almost like fish, carrying early blueprints for limbs inside their bodies. Why would a fish need stronger fins? Because Devonian shallow waters were not always stable. Water levels could fall, pools could shrink, some areas could become dangerously low in oxygen. A fish built only for open water swimming could become trapped when the environment changed. But a fish with powerful fleshy fins could support itself against the bottom, push through vegetation, turn inside shallow water, and move through places where ordinary swimming was difficult. These fish had no idea that this apparently small upgrade would eventually produce one of the greatest boundary crossers in Earth's history. Vertebrates were beginning their long journey toward land, but do not imagine a fish crawling onto shore and turning into a frog. The next morning, the invasion of land was not a single leap, it was a long reconstruction project. The bones inside the fins became stronger, the connection between the head and shoulders changed, the body became better able to support its own weight. Breathing systems also began to change. Transitional animals such as Tiktaalik still possessed many fish features, but also showed traits associated with early tetrapods. It still lived in and around shallow water, yet its body already seemed to contain part of the plan that would eventually carry vertebrate life onto land. At the same time, another revolution was taking place above the water. Forests appeared early in the Devonian. Most land plants were still relatively small, but later, some plants began growing taller. Roots pushed deeper into the ground. Branches and leaves spread above the landscape. The first true forests began covering areas around rivers and wetlands. It looked peaceful, but plants were among the most powerful engineers of the Devonian world. Roots broke apart rock. They helped create and stabilize soil. They changed the parts of rivers, and as enormous amounts of plant material grew and died, they altered the carbon cycle, the atmosphere, and the flow of nutrients into the oceans. While fish were building new weapons underwater, forests were quietly rewriting the operating system of the entire planet. But the Devonian boom did not end gently. Something began going wrong. In the oceans, oxygen levels fell. In parts of the deeper water, reef ecosystems collapsed. Animals that depended on shallow seas and reefs began disappearing. The late Devonian extinction was not one sudden explosion, like an asteroid impact. It was more like a long, repeated clearing event. One crisis struck, the ecosystem began to recover. Then another crisis arrived. Sea levels changed, the climate shifted. Large regions of the ocean became starved of oxygen. Nutrients flowing from the land may have made some of these problems even worse. Together, these pressures turned parts of the ocean into expanding dead zones. Reef systems vanished, many marine species disappeared, and the placoderms, the armored rulers that had dominated the Devonian seas, could not survive forever. By the end of the Devonian, their dynasty was over. That is the great irony of the age of fishes. The thickest armor could not stop the environment from changing. The most dangerous jaws could not bite oxygen back into the ocean. Dunkleosteus and the armored fish rulers left the stage, but sharks survived, bony fish survived, and the strange lobe-finned fish that had begun exploring shallow water continued along the path toward land. Earth proved the same lesson again. The species that lasts the longest is not always the one that looks strongest. At its peak, it is often the one that can change its way of life. When the rules change, during the Devonian, Earth upgraded fish into armored rulers. Then, at the height of their power, it dismantled the world they understood, but the Devonian left behind three enormous legacies: a far more complex world of fish, the first great forests, and vertebrate pioneers preparing to challenge the land. The armored fish dynasty was finished, but the countdown to life on land had only just begun. Next stop, the Carboniferous. Forests would rise over the continents, amphibians would expand, oxygen levels would climb, and the arthropods living beneath those forests would be upgraded into the giant insects of a completely different world.